Abu Ali al-Hasan ibn al Haytham, known in the West as Alhazen, stands as a towering figure in the history of optics, mathematics, and astronomy. His magnum opus, the Kitab al-Manazir, or Book of Optics, completed circa 1025, represents a monumental achievement, synthesizing and significantly advancing the understanding of light, vision, and perception. This work, far from being a mere compilation of existing knowledge, offered a revolutionary approach to the study of these phenomena, grounded in rigorous experimentation and mathematical analysis. It supplanted prevailing Greek theories and laid the foundation for the scientific revolution in Europe centuries later. To appreciate the magnitude of ibn al Haytham's contribution, one must understand the state of optical theory before him. The dominant perspectives were those of Euclid and Ptolemy. Euclid, in his Optics, treated vision as emanating from the eye in straight lines, actively scanning the environment. Ptolemy, in his own Optics, built upon this emissive theory, incorporating elements of intromission, suggesting that the eye also received something from the object. Both theories grappled with explaining how we see, but they lacked a firm foundation in empirical observation and mathematical modelling. They struggled to account for phenomena such as the perception of size and distance, optical illusions, and the behaviour of light in different media. The explanation of binocular vision also remained a largely unexplored territory. Ibn al Haytham's Book of Optics decisively refuted the emissive theory. He meticulously demonstrated through experimentation that light originates from luminous objects and travels in straight lines to the eye. The core of his argument rested on observations of the behaviour of light rays, shadows, and reflections. He described a camera obscura, noting how an image of the outside world is projected through a small hole onto a surface inside a darkened room, providing tangible proof that light travels in straight lines and carries information capable of forming an image. A crucial element of Ibn al Haytham's theory was his detailed anatomical description of the eye. He understood its different parts, the cornea, lens, and retina, and their respective roles in the visual process. He correctly identified the lens as the primary site of refraction, where light rays bend before reaching the retina. He proposed that the image is formed on the retina and transmitted to the brain for interpretation. This was a significant departure from earlier theories, which often located the seat of vision within the lens or the optic nerve itself. Moreover, Ibn al Haytham addressed the perplexing issue of how the brain perceives a single, coherent image from the two images received by the eyes. His explanation involved a complex process of analysis and comparison within the brain, where corresponding points on the two retinal images are matched and combined to create a three-dimensional representation of the scene. This insight foreshadowed later developments in the study of stereopsis and binocular vision. The Book of Optics also delved deeply into the phenomena of reflection and refraction. Ibn al Haytham conducted extensive experiments with mirrors, both plane and curved, to determine the laws governing reflection. He demonstrated that the angle of incidence equals the angle of reflection, a fundamental principle of optics. His analysis of refraction was equally groundbreaking. He investigated how light bends when passing from one medium to another, such as from air to water. Although he did achieve an accurate mathematical formulation of the law of refraction, now known as Snell's law, his work paved the way for its eventual discovery. He understood that the amount of bending depends on the properties of the two media, and he attempted to quantify this relationship. Ibn al Haytham's methodology was revolutionary. He emphasized the importance of combining mathematical reasoning with experimental observation, a hallmark of the scientific method. He meticulously designed experiments, controlled variables, and recorded his observations with precision. He then used mathematical arguments to analyze his experimental data and draw conclusions. This approach, a stark contrast to the speculative and philosophical methods of his predecessors, marked a turning point in the history of science. The immediate impact of the Book of Optics within the Islamic world is difficult to ascertain precisely. While it was undoubtedly studied and appreciated by scholars, its influence seems to have been somewhat limited, perhaps due to its length, complexity, and the lack of a printing press to facilitate its wide dissemination. Nevertheless, it influenced later Islamic scholars such as Kamal al-Din al-Farisi, who wrote an extensive commentary on the Book of Optics. Did make its way to Europe. It was translated into Latin in the late 12th or early 13th century, and it quickly became a standard text for scholars and scientists. Its influence on European thought was profound. Robert Grosseteste, Roger Bacon, and Whitelaw were among the prominent figures who drew inspiration from Ibn al Haytham's work. Grosseteste, a pivotal figure in the development of scientific thought at Oxford, emphasized the importance of mathematics in understanding the natural world, a view strongly influenced by Ibn al Haytham's approach. Bacon, renowned for his advocacy of experimental science, similarly acknowledged Ibn al Haytham's contributions hailing him as a model for aspiring scientists. Whitelow, a Silesian scholar, produced his own treatise on optics, Perspectiva, which relied heavily on ibn al Haytham's. Ibn al Haytham's influence extended beyond optics. His emphasis on epistemology, especially the need for critical assessment in accepting knowledge claims, impacted philosophers. He advocated for rigorous scrutiny of hypotheses and conclusions, urging scientists to verify their findings through independent observation and experimentation. This principle of skepticism, coupled with empirical verification, became a cornerstone of the scientific The legacy of ibn al Haytham is enduring. His book of optics transformed our understanding of light, vision, and perception. His emphasis on experimentation and mathematical analysis paved the way for the scientific method. He stands as a testament to the power of human curiosity and the importance of rigorous inquiry in unraveling the mysteries of the natural world. Even now, centuries after its completion, his work continues to inspire scientists and scholars alike. His meticulous approach and the depth of his insights serve as a constant reminder of the intellectual heights that can be achieved through dedication, critical thinking, and a relentless pursuit of knowledge. He corrected long-held beliefs and offered a new path to understanding the world around us. This impact is a testament to the enduring power of observation, experimentation, and the scientific method, principles which Ibn al Haytham championed so effectively and which continue to guide scientific inquiry today. It is perhaps ironic that a work so instrumental in shaping modern science arose from a culture often viewed through a lens of historical prejudice. The Book of Optics stands as a powerful reminder of the shared intellectual heritage of humanity and the importance of recognizing contributions from all cultures and civilizations.